Hello everyone, today we are looking at Trigonometry Lesson 4. So last lesson we looked at calculating the side length of a triangle, and now we are going to look at calculating the angle of a triangle. So I'm going to skip this little review bit. This was from Lesson 2 that we skipped. So calculating the measure of an angle, it's the same process as calculating a side length, but when it came to, hang on, won't let me scroll. When we were looking at triangles before and we were trying to calculate a side length, what we would have is one angle, we would have one side, and we would be looking for another side that's supposed to be an x. So there's three pieces of information in all these trigonomic ratios. So when you have an angle and a side length, you can find another side length. When it comes to looking for angles, so in this triangle down here, we're looking for angle A, we need to have two side lengths in order to do it. So we need two out of the three pieces of information. It was the same with side lengths up here. We needed two pieces of information to find a third one. So the first thing we're going to do is label this triangle. The side across from the angle. So now it's not a known angle, but it's the angle we're looking for, and it's the same idea. So the side across from the angle we're looking for is the opposite. The side across from the right angle is the hypotenuse. A little bit of lag in the pen here, I apologize. And the side between the two, the angle you're looking for and the right angle is the adjacent. So now what you want to do is you look at your SOHCAHTOA and you look at the two side lengths that you have. You have 34 and 16, which is your hypotenuse and your adjacent. So now we're going to look for a trigonomic function that uses adjacent and hypotenuse. There's only going to be one, and it's the cosine function. So the easiest way to do this, I'm going to do it in the margin over here. The easiest way to do this is say, okay, I'm using the cosine function. Cos of, it'll be a this time, not x. They've labeled it a. Let's keep up with our cos of a is going to be adjacent over hypotenuse. Okay, that's our formula. I like to write it down because then I can fill in and be sure that I'm not making mistakes. All right, so let's fill in what we know. Cos of A is equal to, well, the adjacent is going to be 16, and the hypotenuse is going to be 34. That's a ratio that we know. We know the adjacent, we know the hypotenuse. There we go. So there's two different ways that you can go about this. You can figure out what 16 divided by 34 is. Let me pull up my handy dandy calculator here. 16 divided by 34. And that is going to be cos of A is equal to 0.47. Hopefully you can see that. 0.47. And now we want to find A, but it's wrapped up in that cos function. So what we have to do is use our second cos function, our inverse cos function. So on your calculator, so basically what we're saying is A is going to equal cos to the negative 1 of 0.47. And I know you're asking yourself, wait, cos to the negative 1, what is that? So every calculator has this second button. So you hit the second button, and then you hit your cos button, and you'll see on your calculator what pops up is cos to the negative 1. That's your inverse cos. So when we know the angle and we're plugging the angle into the cos function, there's a number there, we use regular cos. But if we are looking for an angle, so if you're looking for an angle, you end up using the inverse cos. So if you type that in to the calculator, you just hit second function, cos. This cos -1 pops up, and you put in 0.47, you will get 62. That means that that angle A is 62 degrees to the nearest degree. I'm sure there's some rounding there or something. So just to fill this out, cos of A is equal to 16/34. So we do the inverse cos of the ratio, and we get 62 degrees. The other way you can type this in is you can skip this step right here where you make it a decimal. And if you really want to, just to save some time, you could type it in as cos to the -1. And when that bracket pops up, you do 16 divide by 34 and then close the bracket. It's important that you close the bracket because if you don't, sometimes your calculator will do cos to the -1 of 16, find that function, and then divide it by 34. But you want to do cos to the -1 of that entire expression. So you want those brackets to wrap around that whole fraction. But if you do that, then it should be good. You should be good. And it might not look like 16/34. It could even look like cos to the -1, 16 divide by 34. And that should give you the same answer. Let's try a couple of practice problems. Okay, so what angle are we looking for? It says, in each case, calculate the measure of the indicated angle to the nearest degree. Well, they're indicating they want us to find angle A. From angle A, I know that 4 is the opposite, 6 is the hypotenuse, and the adjacent's over here just for good measure. Scroll a little bit if it'll let me. There we go. So, using my SOHCAHTOA, it's very handy just to have that written down somewhere. It only takes 1 second. I see that I have my opposite, which is 4, and my hypotenuse. So the ratio I'm going to use is the sine ratio. So it's sine of A is equal to opposite over hypotenuse. So I can now write it as sine of A is equal to 4/6. I'm looking for the angle, so I have to use you're right, your inverse sine. So now what you're going to do is say A is equal to the inverse sine of 4 divided by 6. And then hit enter. And when you do that, you get A is equal to 42 degrees. Now it's important, if you end up doing regular sine of 4 divided by 6, you're going to get some really small decimal. And then you're going to ask yourself, does that really make sense as an angle? And, it shouldn't. You shouldn't have a weird decimal angle. It should be, between 0 and 90, I guess. Okay, let's do C. So the angle we're looking for is angle C. I can see that I have across from that is the opposite. The longest side is the hypotenuse. And the side between the two angles, the right angle and the reference angle, is the adjacent. And you can see in this example, we have all 3 sides. When we have all 3 sides, we can choose any of the ratios we want. It doesn't matter. And we should still get the same answer every time. So let's, for fun, do a tan ratio. I don't think I've done a tan ratio yet. So I'm going to say, well, tan of A is equal of C, sorry. We're doing angle C now. Tan of C is equal to the opposite over the adjacent. So if I fill that in, the opposite is 21. The adjacent is 20. When I'm looking for an angle, I use my inverse function, tan to the -1 of 21 over 20. Type that in to my calculator, second function, so that second button, and then my tan button, and then 21 divided by 20, and it comes out to be 46 degrees. 46 degrees. Awesome. So the next thing I want to talk about is angle of elevation and angle of depression. So these are just words that come up in a lot of word problems when we're dealing with triangles, and it's important to know what's what. So the angle of elevation is an angle measured upwards from a horizontal line. So you can see in the picture here to the right, we have a helicopter and a boat, and the horizontal line is assuming it's the water there. The angle of elevation of the helicopter from the boat is from the boat's horizontal line, because it's the angle of elevation. The angle of elevation of the helicopter from the boat. So we're starting boat level, and we are elevating. And then angle of depression is a measure downwards from the horizontal. So the same picture here, the angle of depression of the boat from the helicopter. That means we're starting from the helicopter's horizontal, and angle of depression is going downwards. So you can see that if we are using right angles here, that the angle of elevation of the helicopter from the boat actually equals the angle of depression of the boat from the helicopter. That's kind of cool. Just words that we should get used to. So I'm going to do one more example here, and then we will get to it. So here it says a tree 5.1 meters tall casts a shadow 7.5 meters long. Calculate the angle of elevation of the sun to the nearest tenth of a degree. So the first thing I'm going to do is say, well, that tree is 5.1 meters tall. The shadow is 7.5 meters long. I'm going to draw a nice red line through here to show that that's one side of our triangle. Apparently we have a sun somewhere up here. And we're looking at the angle of elevation of the sun. So that means from our horizontal, which is this one here, we're looking for an angle moving upwards. So what you can do is draw a line. So the sun would be casting a shadow like that. So we're looking at, I didn't draw it perfect, but that's okay. We're looking at this angle right here. So let's put a little X there. Maybe we'll use X. X is a nice one. This is a fun fact. When you do a lot of trig, they don't often use X as the variable for representing an angle. They use a Greek letter. It's called theta. So it's like an O with a line through it. So we can write that as theta degrees. It's just a variable, right? It's just like X or Y. So as you get into like upper level math or higher math, you end up using a lot more Greek letters to represent things. So let's label our triangle. Well, the tree side is the opposite because it's opposite from my angle I'm looking for. The long side of the triangle is across from the 90. So this is my hypotenuse, and that makes this one here my adjacent. So I'm trying to find an angle, and I have my opposite and I have my adjacent. So if I look at my SOHCAHTOA, I am looking for a tan ratio because I have opposite and adjacent, and tan is the only one that has opposite and adjacent. So tan of theta is equal to opposite over adjacent. So that's going to be tan of theta is 5.1 over 7.5. And again, if you don't want to punch fractions into your calculator, or you always seem to make a mistake while you do that, what you can do is in your calculator, just do 5.1 divided by 7.5, and that is equal to 0.68. And now I can, instead of putting this fraction into my tan function, I can put this decimal in there, and it's still going to give me the same thing. So theta is equal to the inverse tan function of 0.68. So to get to inverse tan, we hit second on our calculator and then the tan button. And it should come up with a tan to the -1. And then bracket, we put in 0.68 and we click enter. And the angle of elevation is, they want it to the nearest 1/10 of a degree. So it's going to be 34.2 degrees. Yay. All right, so that's finding an angle. It's the same process every time. It only works with right angle triangles, right? The trig only works with right angle triangles. Now we can find side lengths, we can find angles, we can find everything, all the information we need about triangles. We have one more lesson that'll be over the weekend, and I think that's just putting it all together and solving angles and sides at the same time, or in the same question anyways. Cool, thanks for watching. Don't forget to like and subscribe.